Okay, we're back to IPv6 again, and we have Haakon Ringberg from Princeton talking on some work he's done with Danny McPherson.
Hi everyone, I'm Haakon Ringberg. I'm a PhD student at Princeton University, where I work with Jennifer Rexford. This work is not with Jennifer Rexford, though. It's work I did while I was an intern at Arbor Networks this past summer, and my collaborators are listed on the slide, Craig, Danny, and Scott. So as the title suggests, this is yet another IPv6 talk. I'm sure you're thrilled. We, however, looked at traffic data, and I think a lot of people up until this point have had only indirect estimates of the amount of IPv6 traffic on the internet. So I hope first to put this talk into a bigger context from Arbor's perspective, a bigger measurement push that Arbor is going through right now. Then I will talk about why you might care. I'll repeat why you might care about an IPv6 measurement talk, introduce our methodology, the key results, and then to preempt some possible objections. We got some feedback, mostly very positive, but some complaints with the methodology. So I'll go over some potential weaknesses with the methodology. So if you're itching when I present the methodology to complain, you're of course welcome to scream at me, but I might cover it later. So like I said, what we wanted to do is provide a global and longitudinal perspective on the amount of IPv6 traffic that we observed in the internet. And this really is part of a bigger push at Arbor to leverage their deployments, the probes that they have in the field, to provide a perspective on all of internet traffic. Sort of on the one hand, any kind of traffic, where is it going, what services, applications, and what's the rate of growth, and on the other hand, the pervasiveness of certain specific types of unwanted traffic, such as DDoS attacks. So they want to leverage their, I guess, approaching 3,000 deployments now, and have networks participate in this voluntarily to share anonymized data with Arbor. So, like I said, again, it's voluntarily participating ISPs. They share some anonymized data. Here you have, in this little diagram, toy diagram, 3 networks that have bought Arbor gear, perhaps Peakflow or something, and they send data then back to the mothership for Arbor to analyze, perhaps in an offline setting such as this, or in real time. These networks categorize themselves according to their type and their predominant geographic coverage. The data set, what we get is traffic in and out of a network, binned into 5-minute samples, the top protocols, ports, the ASNs where traffic is coming from and going to from the given network's perspective. And it's largely based on IP flow measurements as opposed to DPI. And we've had this thing going for, I guess, 2 or 3 years, but for today we're doing a 1-year measurement period. This slide is mainly to impress you. It's a little old. I guess the high-level message is that there are 65 networks in the Americas, 27 in Europe, Middle East, and Africa, and 6 in Asia. And at the end of our measurement period, we had a daily average of that exceeded 5 terabits per second of internet interdomain traffic in this data set. So we believe it's the largest of its kind. So now I've given you the sort of big lay of the land and sort of the measurement push. More specifically, why Repeating, why might people care about the IPv6? Well, we're running out of addresses, or more specifically, the IANA and the RARs are running out of unallocated address space. The exact date when the internet will implode or explode, there is some uncertainty about, but I guess it's within the next few years. 18 months was mentioned. Luckily for all of us, IPv6 fixes all our ails. It has something on the order of 28 orders of magnitude more addresses, so that should be sufficient for a couple of years. And because we have this big problem and there is an available solution, there has been some government pressure in various parts of the world for us to make this transition. The OMB in the US mandated that IPv6 be available on routers. And in China, there's the Next Generation Internet Initiative, which, among other things, pushes for IPv6 adoption. Okay, so we have this problem, this solution, and people are pushing for us to make the transition. How's that going for you all? And ideally what we want, the direct measure, is an understanding of the amount of IPv6 traffic that is on the internet. Unfortunately, as people have mentioned today, and I can certainly attest to as an academic, it's really hard to get network operators to just share all their traffic data with you for various largely understandable reasons. Therefore, we have primarily indirect estimates of how much IPv6 traffic there is on the internet. So this is sort of the related work and was talked about earlier. 3% is the fraction of ASNs with IPv6 BGP announcements. That's a fairly small number, but it's larger than 1%, which is the fraction of Internet 2 sites with a passing IPv6 grade. A little disappointing. One might expect them to be ahead of the curve, or maybe they are. Even more disappointing is that 0.4% of the biggest websites, according to some methodology, are using IPv6. And finally, as you may predict, there's an even lower number, which is 0.2%, which is the IPv6 DNS queries as a fraction of the IPv4 DNS load. So we've got very small numbers here. There's an order of magnitude difference between the smallest and the largest, but they're all small. So our contribution is to provide another number to this, but one that is that directly states from our 5 terabits per second of average daily throughput traffic trace, the fraction of IPv6 in that trace was it was between 0.02 and 0.003%. So that I think you will agree is very small. So now I've told you the final number and the broad methodology. So a little more specifically, what is IPv6 internet traffic in our case? Well, I've told you what traffic is. That's largely from flow-based measurements. By internet, we mean interdomain. So this is traffic in our trace that crossed an AS boundary. And for IPv6, we wanted to cover both native and we wanted to look at the two primary forms of tunnel traffic. For the native, it requires, for us to be able to monitor it, the router has to have NetFlow v9. We have, of the two forms of tunneled, we have IPv4 protocol 41 tunnel traffic, and then Teredo traffic, which is tunneled over UDP port 3544. Here's another graph primarily meant to blow you away. This is the total traffic that we observed in our data set. So approaching 5 terabits per second in this graph. On the bottom you have time, roughly end of July 2007 until end of July 2008. On the y-axis you have throughput in terabits per second daily average. The bottom blue is the Americas. You have Europe, Middle East, and then Asia at the top. So it's a lot of traffic. Hopefully a representative sample of internet traffic. So first, the denominator, the good news, IPv6 traffic is growing. On the bottom here, you have, again, time on the x-axis. The y-axis is megabits per second of IPv6 traffic. The blue is tunneled IPv4 protocol 41. The green is native. You're not blind. There is no green. The red is Teredo at the top, the little thin layer there. The good news is that we see, if you take the first quarter and the final quarter of our measurement period, we see a 30% increase, and it's approaching 150 megabits at the end of our measurement period. So that's the good news. 150 megabits, can sound like a kind of impressive number, but of course it's not all that impressive when compared to 5 terabits. And again, you have here in the graph time on the x-axis, and on the y-axis, there's the percent bits per second of IPv6 as a function of the total traffic that we saw in our data set. This is not 0 to 4%. It is 0 to 4 when scaled by a factor of 10 to the negative 5. So that 3 there is 3 thousandths of 1% IPv6 traffic. I think you will agree that is very small. And the other thing is, while there is increase in our data set of the amount of IPv6 traffic that we observed, it is in fact growing slightly slower than overall internet traffic. So when compared to overall traffic, it's actually stagnant. And that pretty much are the results for my talk. We went looking in our giant data set for IPv6 traffic, and we didn't really find much. But we have this. We released a tech report, a month or two ago, and this slide isn't. I didn't even make this graph. This was generously donated by the kind folks at Hurricane Electric. It just demonstrates that our report had an immediate, profound impact on industry. On the x-axis of this graph, you have time. On the y-axis, you have tunnel broker account signups for Hurricane Electric. So right when we released our report, there was a doubling in the amount of people signing up. The good news, I guess. So potential objections to the methodology. So the one that we heard a couple of times is that we weren't monitoring your network. I guess the corporate perspective there is that's super. Please call Arbor today, and they would be happy to sell you boxes and include you in the measurement study. The slightly more scientific response is that at 5 terabits per second, it's certainly the largest study today that I'm aware of, and hopefully you believe that it's representative. There is a North American, also on the sort of selection of networks, there's a North American European bias. There was about a 1 terabits per second at the end of traffic from Asia, but yes, there was a North American European bias. We also focused on interdomain traffic. Some people have been saying that there is more IPv6 intradomain. That is something we have access to that data for the networks in question. So we hope to look at that in future work. And also for future work, again, this data set is flow-based primarily. We also hope to do a measurement study based on DPI data. Perhaps IPv6 traffic is hiding in other ports. Then final slide of the objections. It's possible we're undercounting native IPv6 traffic. Like I said, for us to measure it, monitor it, the router needs to have v9, and it seems that v5 is the flavor of choice. On the one hand, I can punt on this and say, hey, that's not my fault. The router, the network operators need to make this transition. The other point is that someone somewhere made the determination that it wasn't necessary to do this upgrade to perform this monitoring, and so one can read things into that. It's also possible that we're undercounting Teredo traffic because my understanding of the protocol is that the realizing servers listen on 35, 44, but subsequent data traffic need not. We looked into this a little further. Scott looked into it a little further and found that, there are only 2 of our 100 deployments that saw more than occasional few kilobits per second of traffic on this port. So there wasn't a lot of relay and server traffic. So if we're undercounting it, we're probably not undercounting it by much. And as you may recall, the Teredo was just a very thin line up there. So even if you multiply it by a factor of 10, it's not going to change the fact that 0.003% of traffic is IPv6 in our data set. Okay, so to conclude quickly, we took a look in our data set. We found some IPv6 traffic, very little. There is some growth, but not compared to overall internet traffic. So largely negative news, I suppose. My talk is mainly a measurement talk, deliberately dry and boring, but perhaps, and other people have much more eloquently argued for why there has been this sort of lack of a transition. But very quickly, from a lot of networks' perspective, transitioning to IPv6 represents probably a net outflux of money, at least for now. There's a cost associated with the hardware-software transition upgrades, but not clear that there's any added revenue. It's also a chicken and egg problem, like people have pointed out. There are no users, so content providers don't feel a need to upgrade, and there's no content, so users don't feel a need to upgrade. We haven't had that killer IPv6 app, except for the dancing turtle. And then it's perhaps understandable, a lot of people have the opinion, at least from my perspective right now, IPv4 is working well. Why should I mess with my network? So then I'm going to end, let you go to lunch early, and I will be happy to take any questions. Thank you.
Jay Hennigan with Impulse Internet Services in Santa Barbara. As far as IPv6 content, it seems to me that one of the things that is preventing this is the large number of broken IPv6 implementations out in customer space. And that if, for example, I know that Google has IPv6.google.com, which works very well. But my understanding is that if a number of websites, if they were to put a quad A record for example, www.google.com, that people who are running an IPv6 stack that don't have IPv6 connectivity would break. And so the problem is that I don't know how to resolve that, but that to me seems to be a major stumbling block for getting IPv6 content out there. It has to be made somehow transparent to the users so that they essentially go to the same site and it just works. So I think that the customer space needs to have some major upgrades so that if they get a quad A record and they don't have IPv6 connectivity, that it will relatively quickly and seamlessly fall back to v4.
I completely agree, and I suspect it's probably one of several major stumbling blocks. Please.
Alain Durand, could you please go back to your Teredo slide?
Stop me.
Doesn't matter. You're counting the traffic on the well-known UDP port number.
Yes.
So what you're doing is you are counting the signaling traffic to Teredo. You are not counting the data traffic.
Right.
So the data traffic is several orders of magnitude larger than the signaling traffic. So
right.
what you are measuring is actually irrelevant to Teredo.
Right. So
that's actually where the action is right now. There are some peer-to-peer applications that are in that space, that you are not counting.
Right. So you agree that the relays and servers have to they synchronize on this port.
That's only the first packet.
Right. So even if we multiply that by 2 orders of magnitude,
well, it doesn't mean anything. The signaling and the data are completely unrelated.
Okay.
So if you do not measure the data path, you do not measure anything.
Okay. So that's the need for DPI measurements, certainly. I guess I would, sure, that DPI measurements are necessary.
Yes.
Go ahead.
I'm Martin Lieber from Haakon. Could you go to the penultimate slide, your conclusions?
Certainly.
And stop. I wanted to know what packet filtering you used in order to understand the money, high cost, no added revenue part. Where were you filtering to understand the revenue aspect of V6?
I mean, this is, I don't understand it. There was no, I don't understand the question.
Okay, I just wondered why there was revenue in that because nothing from what you said had anything to do with revenue up to this point. Okay, traffic on AMS6, 0.1% at the moment, sitting as V6. Mm-hmm. Major difference from what you're seeing on your numbers. You're down in the
what transits?
So that's just on the AMS6 exchange in Amsterdam. Second question is, on all of the networks that you measured for this data,
right,
did you have any of the major V6 backbones within your measuring set?
Any, I can't answer that off the top of my head. I mean, there are other measurements out there, and I don't know their methodology when compared to ours, so it's impossible for me to answer.
Okay, so does that mean that there's a measure of what's your confidence factor on this number?
I am completely confident that this answer represents the fraction of IPv6 as in our data set of a 5 terabits per second data set.
Okay.
Hello. Patrick Elmer
Please.
from Martin, the 400 megs on AM6 is actually almost all news peering from a single provider. I don't think it's representative of the whole internet since they only offer it over the AM6. That's the only place you can get it. And if you turn that news peering off, it drops by at least 2 orders of magnitude. So the AM6 thing is a little off. That doesn't mean that there's not more traffic in general. I'm just saying that AM6 is a bad data point to say that this data set presented in the slides is wrong.
Thank you.
Randy Bush, IIJ. We're arguing over how powerful a microscope you need to see the V6 traffic. All of the microscopes are pretty broken. I do internet measurement. It sucks when some serious computer scientists are measuring your product as a behavioral phenomenon. You are in trouble. And it's a turtle and egg problem, not a chicken and egg problem.
Jeff Houston, I must admit, this whole issue of exactly what you're measuring and what does it mean really becomes a problem. I looked at this same thing about traffic, and the problem with a lot of the traffic we actually see on the network is heavy tail distribution. There's an astonishing amount of large traffic flows where the volume is high but the number is low, and an awful lot of folk with very short traffic flows where the volume is extremely low per flow, right? Mm-hmm. So what do you mean when you say, I've looked at traffic, versus what does it mean to say an industry is making its steps towards migration? And part of the reason, I suppose, why I, in looking at what was happening at a web server, really didn't bother about trying to look really hard about the amount of traffic, was that I'm not sure I understood what I was measuring when I was getting my microscope out to look at the packets. It just didn't seem to make much sense in terms of what's the real question I'm trying to answer.
So absolutely, and I mean, I didn't mean if it was, I didn't mean at all to say that the related work was not very useful, and I think each of the different metrics that you choose to measure will have weaknesses, and are useful for some things.
Normally, just to wrap this, you've looked at 5 months.
What's that?
You've looked at 5 months here, September through to
it's a year.
So what was it like a year before, and the year before, and the year after? Some ways, when you actually don't know what you're measuring in reality, as long as you keep on doing it, the comparison between what happened before and what happens in the future then becomes the interesting bit. It's the first order differential that then becomes, the actual metric you're after. That seems amazingly flat, but that's an amazingly short sample.
A year?
In this kind of world, yes, we move very slowly, evidently.
Please.
Hi, Elisa from M6. I just want to add to the previous discussion that we measure native IPv6 traffic based on S-flow data we have, and it was true indeed that it was in the beginning caused by basically one provider who enabled new services over V6. And that is not true anymore, at least from what I can see in the growth that happened. I mean, we do about 800 megs, I believe, and 200 of them were this first provider who enabled it half a year ago. Thanks.
Okay, is that all questions? Okay, thank you, Haakon. Oh, wait a minute, one more from Randy.
Talk is cheap. How many providers here, Randy Bush, IAJ, sorry. How many providers here have public SMTP servers that are accessible over IPv6? Web servers, DNS servers. Okay, could some researcher actually take this measurement, not by raised hands, by actually doing something like taking an analog list, going to the side, and find out, through all this BS, are we as a community actually deploying IPv6? Are there going to be more turtles than eggs?
Okay, thank you.
Thank you.
Well, we're ahead, so we have one more question from John.
So, John Curran, I'll put my Aaron hat on, make it really clear. Chairman of Aaron. We don't have to deploy IPv6. If you don't need more addresses, when the central RIRs run out, when the central red pool runs out, and then the RIRs run out, there may be some reclaimed. You're all going to mine your own infrastructure. You may go back to customers and say, hey, I really want the other half back because you're not routing it and I need it. There'll be some soft places you can recover. But you don't need to deploy V6 unless you're relying on the fact that you continually need new addresses to connect new customers. That doesn't apply to everyone in the room, but it does apply to some folks, and they're aggressively deploying V6.
Okay, well, before we quit for lunch, I have one thing to remind you of, which is to please vote, if you haven't already done so, in the steering committee elections. You have 28 minutes before the voting closes at 1 p.m., so it'd be nice to see more votes. And, of course, don't forget to complete the survey before you leave. There's plenty of them lying around, or you can do it online. Okay, it's lunch on your own now. We restart at 2:30.